Welcome back to Jack Noonan Geography. I'm your host, Jack Philson, and today we're going to be talking about what is the most fascinating force of nature in the world. And since I'm the host, I obviously get to decide that. And in my opinion, the most fascinating force of nature is acid rain. And in today's episode, we will be talking about why acid rain is the most fascinating, and maybe some other fun stuff as well, but you gotta stick around to find out. So you might be wondering, why is acid rain so fascinating? And there are loads of reasons why I think it's fascinating, but that's actually a lie. There actually aren't. Acid rain is a pretty rare thing to come up on, and I had this feeling that it's hard to distinguish something that's bad and something that's fascinating. It's kind of like separating the artist from the art. Like, obviously, I like Kanye West music, but what he's done is, like, not very good. So, I think acid rain, albeit not very good for the environment, can still be interesting in its own way. So, the first point I want to talk about is the chemistry of acid rain. So, when sulfur dioxide, aka SO2, and nitrogen oxides like NO3, NO2, NO4 enter the atmosphere through various ways and react with water in the air, because there's a whole lot of water in the air, they create sulfuric acid and nitric acid. This is bad, as acids are pretty bad, and hence the name acid rain. So this chemical reaction is a synthesis reaction, which means that they're combining water and these acids. They're combining to form sulfuric acid and nitric acid because they displace. But why does this reaction happen? Well, it is actually on us, because acid rain happens because we burn fossil fuels like crazy, and yeah, that's about it. Honestly, it makes up so much that all the other sources of acid rain don't even really compare to fossil fuels. Like a heavy machinery use and oil manufacturing is another cause, but the fossil fuels is like 9 to 1. It's only really the fossil fuels. Actually, I'm reading my notes, and 2/3 of the SO2 comes from electric power generators, according to the United States Environmental Protection Agency. So maybe it's not all fossil fuels, but it is, like, I would say 80 to 2 fossil fuels to other stuff. Another cool chemistry fact is that the pH level ranges from 2.4 to 4.4, and that means that acid rain is slightly more acidic than black coffee. So the next time you're pounding back like a double-double from Tim Hortons, just remember that you are drinking something that's less acidic than acid rain. But it's pretty close, honestly. I wrote here, one will give you a boost of energy in the morning, and the other one might give you lung damage. Jeez, that's pretty bleak. Anyways, you might be wondering, Jack, how is this actually fascinating? Well, I have been taking chemistry this semester, and I think it's really neat to see real life stuff and the stuff we're learning. And honestly, now the more I've taken chemistry, the more I see it in geography. Especially now we're doing the unit on rocks and silicants and volcanoes and stuff. Like, there's tons of it. And I just think it's interesting to connect, what we're learning and I guess what we see in real life. Because I don't think not every subject you can do that. Like, geography, yes, you can do that on a scale. And chemistry, I think it's just a bit harder because you don't know, and you have to be knowledgeable in chemistry. But yeah, I think it's really fascinating to see. Switching subjects, probably more back into geography. Another cool fact about acid rain is that it is not just wet. It includes both wet deposition and dry deposition in the form of, water and the acidic particles. In drier areas, the form of deposition can actually be more, I'd say, relevant, because the particles can like actually be like dusted off, which like is weird to think about. Like you're just walking along like Arizona, starts to acid rain, you get some on you, and then the water goes away, but like there's still particles left, and you just wash this off. That's pretty weird, but it's cool that it's both depositions, and I think it's like formed in the acidic deposition. Switching back to a bit of history, the term acid rain was actually coined back in 1852 by a Scottish chemist named Robert Angus Smith. It's a pretty cool name. He used the term during his investigation of rainwater chemistry near industrial cities in England. Oh, and Scotland. Specifically linking air pollution from burning coal to the acidic precipitation. But it wasn't recognized as a major crisis until the late 1960s, 70s. And honestly, I wonder why that is, because just the term alone, acid rain, sounds like menacing. Like, if I knew that, like, acid rain was more prevalent, but I didn't, like, actually know what it was, I would be pretty scared of it. Because you think of acid, you think of, like, the vats of acid where people get melted in. And like, that's raining on me? Like, I'm not trying to stick around. People in England are crazy, bro. 1800s were a different time, I guess, but, like, maybe if you have some bit of common sense. Another reason why acidic rain is more interesting or fascinating is that it is prevalent in some areas more. And these areas typically have a lower buffering capacity. And what is buffering capacity, you ask? That is a great question. And I swear to God, I'm not just reading this off the internet. I'm trying to make this flow. Buffering capacity is the measure of solution's resistance to pH change when a strong acid or base is added. So in this case, the acid would be the, acidic rain. And it just shows like how a place can support having this so much like acidic content in the specific area. Some fights against acidic rain in terms of buffering capacity is actually soil, which is rich with limestone, calcium carbonate, back to chemistry. And these basic compounds can neutralize the acidic compounds, which forms salt and water. Which, we need salt and water. I mean, it's not like actually salt and water, it's like a form of salt and water. But still pretty cool. So we've talked about how acid rain can be fought, but some of its like weaker enemies to say is limestone and marble, believe it or not. So the chemical reaction for this is calcium carbonate plus the sulfuric acid results in a displacement reaction to form calcium sulfate plus water plus carbon dioxide. So I would say most of those things are bad. Carbon dioxide being one. And so what actually happens in this reaction is that the stone literally dissolves. Like it's gone. It goes away. It forms a black crust that eventually cracks and just flakes off, which then results in the stone being like crumbled. And this is bad because this has actually happened globally in two famous historic landmarks like the Acropolis, Taj Mahal, and really anything that's marble statues, gravestones. And this is bad because, at the end of the day, it's really us that's doing this because of us burning fossil fuels. And if this keeps on, like, I feel like stuff is going to get destroyed even further. Like, goodbye Acropolis, goodbye Taj Mahal, because it's going to get destroyed. And that sucks. But that's not really the point of this podcast. So, coming back to more of a geographical approach, acid rain, we know, comes from burning fossil fuels. And these are most prevalent in North America, Western Europe, parts of East and South Asia, and especially China and India. But it does happen all around the world. Because that since it's an air-based thing, prevailing winds, and what these prevailing winds do is that since the acid rain is in the air, it picks it up and it acts as a conveyor belt. It goes everywhere. And since the acid rain is so high in the air, it can spread out further because of gravity and the wind's going down, the wind's going up, and they're just going everywhere. And this is bad, especially because in Canada, a lot of acid rain comes from the industrial Midwest of the United States. Like, another reason to blame and dislike the United States. Acid rain, add that to the list. But, yeah. Now, this is a bit random, and you might not think that this is the case, but mountainous regions are actually more affected by acid rain because of the increased precipitation and the higher elevation, and they get more of that acidic deposition that we talked about. And also, since they're so high up, they almost get consumed by the fog that's also heavily acidic because it hasn't turned into rain yet, because it hasn't precipitated out of being fog. And again, like, that would just be terrible. Like, you're living in the mountain, that's already pretty rough, and then you're just living there, and there's just a big cloud of acidic fog. And you can't breathe it in, because it's acidic and it's poisonous. And it's just there, and you can't really get rid of it either. And so what's the result? It just turns into rain, and now it's pouring on you. Another reason I would not live in a mountain. And another thing is that, say you're living in like a snowy place, but it's kind of warm, like Toronto. And it's one of those weird days where it's March and it's just snowed, but now it's suddenly like +10. What can actually happen is that if the snow melts rapidly, and then that snow was highly acidic due to the sulfuric acid and nitric acid, and it melts rapidly because of the heat, and again, climate change, is that if you're near like lakes or streams, this can almost shock the water because of all that acidic from the acidic deposition in the snow becomes runoff into these streams or lakes. It doesn't have to be like lakes or streams, or streams, would be more prevalent for Toronto, like the Don or Lake Ontario. And then the acid is in the water system, and now we're drinking acid. And not only to us this is bad, but also to like fish eggs, mammals who drink this water as well, birds, reptiles, like all that. Now they're in this acid water. Like, I'm starting to really think that acid rain is just terrible. Like, there's no good thing about it. And I know at the start I said separating art from the artist, but like, I don't know if I can. I'm slowly turning on acid rain. It's like it's villain arc. I'm reading more about it and learning more about it, and it's like this is the villain arc of acid rain. Now, I mentioned before that Asia was a big hotspot for acid rain, and it's actually pretty bad. Like, so China, it has a ton of fossil fuels. It's its source. Then, that source of fossil fuel left in the air, prevailing winds do its thing, and it goes into Japan, South Korea, into India, Vietnam, Malaysia, all those places. Those are the sinks. And it's like, what can even be done about that? And it just shows you really like how one place like China can affect many others without like it's not indirect. It's kind of indirectly doing it because like they don't control like the chemistry of it. But I don't know. Again, it's like, and this is bad. Like I don't know. It's pretty bad. I mean, it does happen here in Canada, but it's not as much. I wouldn't say it is to the scale, but I mean, it's pretty close. I would say it's pretty close. I feel like I'm kind of just jumping all over the place, which I am. I'm not really trying to be discreet on that, which I am. And so, for our next example of something that's fascinating but also seems to be bad, is that depending on where you are more affected by acidic rain, especially plants. Like high elevation plants, yeah, like just wrap it up. Like same thing with the mountains, right? You get more stuff because of higher elevation plus more precipitation. Like if you're high elevation, like you're done for because the acidic rain goes into the soil, and if your soil isn't nutrient rich with like calcium or something like that, like you're done. You're done. But like for example, red spruces are have honestly the worst combination as they're in higher elevation areas, plus their sodium has a low buffering capacity. And so like we have seen in this generation like a decline in red spruce trees because of this acidic rain. And that really sucks because extinction is bad and losing stuff is bad. And for another example, the stuff in the Canadian Shield is, well, one, built on rock, which means it has really bad soil. Like, it's granite based soil, rock based soil. These plants are growing in rocks. And so when we get acid rain, there's no minerals. They're they don't have the essential nutrients to survive. And I don't know, is this worse than forest fires? I don't think it's worse than forest fires, but I would say it's up there. It's like it's pretty bad. And the more I do research on this, it just shows like how acid rain. I'm gonna go on this rant again. Acid rain is terrible. It's terrible. But on a more positive note, I hope you learned something about acid rain, and maybe we shouldn't pollute as much. But that is the end of this first episode. I thought it was pretty good for the first episode. They will be better. They will be better. The next one I want to talk about is the most awe-inspiring landform. I need to do more research, but I will figure out what my personal favorite awe-inspiring landform is. And I will come back, I will sit down, and I will yap about it for 20 plus minutes. And that's the next episode. This is it. I'm Jack Filson signing off. Goodbye.